Hi friends, in this video we are going to solve optimization problem with the constraint. The constraints are equality constraints, inequality constraint, not equality constraint. So equality constraint means we can use Lagrangian multiplier method. So whenever the inequality is placed, we cannot use Lagrangian multiplier method. So that is why we are going for the KKT conditions. So first I want to write, so the given problem into the KKT condition. What is the KKT condition? First I want to write. First one is optimality condition. So dou f by dou xi plus summation j equal to 1 to how many constraints? M lambda j times dou g j by dou xi equal to 0. Here that equation is I equal to 1, 2 and so on n. Here n is the number of decision variable and m is number of constraints. Second is feasibility condition. Feasibility condition means our Gj of x is less than or equal to 0, j equal to 1, 2 and so on m. M is number of constraint, because all are inequality constraint only we can use KKT condition. Third one is complementary slackness property. What is complementary slackness property? Means lambda j times gj of x equal to 0, where j equal to 1, 2 and so on m, and fourth one is non-negative. So here lambda j is greater than or equal to 0, j equal to 1, 2 and so on m. You look in Lagrangian multiplier method, our lambda can be either positive nor negative. Whenever I am going to talk about KKT condition, this is only for minimization problem only I consider. The maximized problem you simply multiply the minus sign of the your objective functions, you will change it, correct? So this is the case. Now we are going to solve this problem using this optimality condition, feasibility condition, and complementary slackness problem. So first I want to do the optimality condition gives optimality condition is dou f by dou xi plus summation j equal to 1 to m lambda j times dou gj divided by dou xi equal to 0. So here number of decision variable is 2, x1 and x2, number of constraint is 2. So this implies, so the here I is, this is you can become 2 and I also 1, 2. So dou f by dou x1 I want to calculate. So for I equal to 1 case implies dou f by dou x1, that is x1 square. So you take derivative with respect to 2x1 minus 4 plus lambda 1 times 1 minus 2 times lambda times 2 equal to 0. Because I want to take derivative with respect to x1, 2x1 minus 4 will come. This guy is lambda times 1 minus 2 times lambda 2 equal to 0. I equal to 2 implies you want to take derivative with respect to x2, 2x2 minus 6 plus lambda 1 plus lambda 2 equal to 0. From the optimality condition I can write. Second one is feasibility condition. From feasibility condition, g1 of x1 comma x2 less than or equal to 0. So g1 is x1 plus x2 minus 3 is less than or equal to 0. Second is 2x1 plus x2 minus 2 is less than or equal to 0. Then complementary slackness property gives I want to take the lambda j times gj is 0. So lambda 1 times x1 plus x2 minus 3 equal to 0. Lambda 2 times minus 2x1 plus x2 minus 2 equal to 0. Then fourth is non-negative property. Lambda 1, lambda 2 is greater than or equal to 0. Now I am going to find the condition. So first of all, I have the here 4 cases will come from the complementary slackness property. Lambda 1 equal to 0 and lambda 2 equal to 0. This is we consider as a case 1. This one we consider as a case 1. So in the case 1 we call it as a case 1, that is there is no constraint, such a thing. So inactive constraint people may call. Second case, lambda 1 equal to 0 and lambda 2 is not equal to 0. This is we can say case 2. Third is lambda 1 is not equal to 0 and lambda 2 equal to 0. This is become case 3. The fourth is, so everything is from our complementary slackness property only. Okay, lambda 1 is not equal to 0 and lambda 2 not equal to 0. This is, we can say, case 4. So now I am going to check what are the things are satisfies all the conditions. Okay, so now for time being I will take this is equation number 1, this is equation number 2, this is inequality, I take equation number 3, 4, 5 and 6. So now you look, these all the conditions are given by 5 and 6. Okay, because two numbers I multiply gives 0. So lambda 1 can be 0 or lambda 2 can be 0 or this guy 0 or this guy 0. So using this fact. Now first I will consider about the case 1. Case 1, lambda 1 and lambda 2 both are 0. So lambda 1, lambda 2 become 0. From the equation 1 become x1 equal to 2, correct? So lambda 1 equal to 0 and lambda 2 equal to 0. This guys become 0, this guys become 0. So x1 from equation 1 implies x1 equal to 2. Equation 2 implies x2 equal to 3. So now it is possible. Now what is the problem will arise? It does not satisfy equation number 3 because x1 plus x2 minus 3 is less than or equal to 0. So it is violates. Violates the complementary slackness, feasibility conditions. Violates feasibility okay. So that means our case 1 is it's not works fine. So case 1 is it's not correct. So I will mark it, it is not working. Now I am going for the case 2. So lambda 1 equal to 0 and lambda 2 is not equal to 0. So lambda 1 equal to 0, x1 equal to, so our first equation becomes lambda 1 only 0. So 2 times x1 minus 4 minus 2 times lambda 2 equal to 0, 2x2 minus 6 plus lambda 2 equal to 0. So lambda 2 is not equal to 0 implies from the 6th equation minus 2 times x1 plus x2 minus 2 equal to 0. So minus 2x2 plus x1 minus 2 equal to, minus 2x1 not x2, minus 2x1, here only x2. Now you look, this is from equation number 1, this is equation number 2, this is equation number 6. So now you can this equation I will say the equation number 7, this is I say equation number 8, this is I can say equation number 9. The 8th equation is multiplied by 2 implies 4x2 minus 12 plus 2 times lambda 2 equal to 0. So 7th equation as it is, I can write it as 2x1 minus 4 minus 2 times lambda 2 equal to 0. If you add together, so 2x1 plus 4 times x2 minus 16 equal to 0. So now I will name it, this equation is 10. So from 9 and 10 you will add. So 9th equation you write it as it is, minus 2x1 plus x2 minus 2 equal to 0. If I add together, 5x2 minus 18 equal to 0. This implies x2 equal to 18 divided by 5. If you know what is x2, then what about the x1? You will substitute any one of the equations. So 9th equation also you can directly apply. You will apply minus 2 times x1 plus x2 is 18 divided by 5 minus 2 equal to 0. So this implies x1 equal to 9 divided by 5 minus 1. So we will get it as 4 divided by So once you find the x1 value is 4 divided by 5, now x1 is 4 divided by 5, x2 is 18 divided by 5, it does not satisfy again, correct? So one of the condition is x1 plus x2 is minus 3 is less than 0. This guy is become more than 3 will come. So 22 divided by 5 minus 3 is beyond. So it is also again, it violates feasibility condition. Against feasibility condition. So our second case also fails. It did not work. Now I going for the lambda 1 equal to 0 and lambda 1 equal to, so now previously I find lambda 1 equal to 0. Now lambda 1 is not equal to 0. This case 3. Case 3 is lambda 1 is not equal to 0, lambda 2 equal to 0. So our equation number 1 implies 2x1 minus 4 plus lambda 1 equal to 0, then 2x2 minus 6 plus lambda 1 equal to 0. From equation number 5, lambda 1 is not equal to 0. Then these two guys are multiplied give 0. x1 plus x2 minus 3 equal to 0. x1 plus x2 minus 3 equal to 0. So now I will say this equation number is 11. This is equation number 12. This is equation number 13. I will name it. Now 11, equation number 11 minus 12 implies, so that will come 2x1 minus 2x2 plus 2 equal to 0. So this implies x1 minus x2 equal to minus 2. So this is equation number 14. Now 13 plus 14 implies, so x2 will cancel, so x1 become 3 plus minus 2 is 1, x2 1 is 1, x1 is 1, so you apply x2 equal to 2, the lambda 1 value is 2 times x1 is 2 minus 2, lambda 1 equal to 2, and lambda 2 value is, we assumed that already it is 0. So this is satisfies this condition. So x1 is 1 plus 2 is less than 0 is 2. So equation 3 is satisfies, minus 2 plus 1, minus 2 plus 2 it's become 0, minus 2 is less than or equal to. Fourth condition also satisfies. From 1 and 2 we are solving, so feasible condition satisfies, so it is true for all the conditions. So this is our feasible point. So x1 star comma x2 star is 1 comma 2, lambda 1 is 2, lambda 2 equal to 0. So that meaning is my third case is satisfies all the 6 conditions, that is feasibility condition and optimality condition and complementary slackness property. Next is I am going for the case 4, lambda 1 and lambda 2 is not equal to 0, lambda 1 is not equal to 0, lambda 2 is not equal to 0. So this implies what will happen is my x1 plus x2 minus 3 is 0. So from equation number 5 and 6, x1, so we will start with the case 4. x1 plus x2 equal to 3 minus 2x1 plus x2 equal to 2. If I subtract these two equations, so 3x1 equal to, if you are subtract, you will get 1. So this implies x1 equal to 1 divided by 3. If x1 is 1 divided by 3, so x2 equal to 3 minus 1 divided by 3. So x2 is 8 divided by 3. x2 is 8 divided by 3. Now you will apply from the equation number 1, you can lambda 1 lambda 2 value you can find. x1 is 1 by 3. So from equation number 1 implies 2 times x1, so 2 divided by 3 minus 4 plus lambda 1 minus 2 times lambda 2 equal to 0. So this implies lambda 1 minus 2 times lambda 2 equal to 12. So 10 divided by 3. So equation number 2 implies 2 times x2, so 16 divided by 3 minus 6 plus lambda 1 plus lambda 2 equal to 0. So this implies lambda 1 plus lambda 2 equal to 2 divided by 3. Now this is equation number 14. This is equation number 15. I will choose. So lambda 1, the 14 minus 40. So 15 minus, case number 15 minus 14 implies 3 times lambda 2 equal to minus 8 divided by 3. So lambda 2 is minus 8 over 9. It is against non-negative of lambda j. That is the one condition, correct? Non-negative of lambda 1, lambda 2 must be positive. So that is why we will against. Okay, if you are again, you can find the lambda 1, that is meaningless. So it violates. So only case 3 is our actual one. So what is the case 3 is? Case 3 is lambda 1 is 2, lambda 2 equal to 0. These are non-negative conditions. X1 is 1, X2 is 2. So this is the feasible region. So now I want to find f of x1 star comma x2 star. This is the minimum value. X1 is 1, X2 is 2. So our given function is x1 star square. So that will mean is 2 square, 1 square, 1 minus 4 plus 4 minus 12. So this value becomes minus 11. This is the minimal value of the given function using the condition this x1 plus x2 is less than or equal to 3 and minus 2x1 plus 2 plus x2 is less than or equal to 2. I hope you understand what is the KKT condition, how to imply in the problem. Thank you for watching this video.